Hi, this is an example problem about length contraction from Chapter 28 on special relativity. Pause for a moment to read the question. So in this case, we have a spacecraft pilot that's flying. They're going to cross over a runway. And we've given some information about how fast the spacecraft speed is, of course, as measured by an Earth-based observer. And we also know what the runway is, as measured by an Earth-based observer. Question A asks, which person measures the proper length of the runway? Explain. So when we're dealing with length contraction, we've got an equation here, a simple equation that we can use. Again, I've used gamma instead of putting the entire long mathematical expression here, but it's the same thing as what the book does. And importantly, to determine who measures the proper length L0, it says that's measured in the unique reference frame where the two spatial points are not moving. So the 2 points that define the length of the runway are the two ends of the runway. We need to find the reference frame for the observer who measures those 2 points as being stationary. Okay, so I've put the appropriate equations here into the page. And let's go ahead and draw a picture for part A of what the Earth-based observer is seeing here. So here we're on Earth. We've got an observer here. And there's a runway. Let's say it measures from this point over to this point. We might call this, if we want, position. This is the left end. Here's another position, XR, the right end. Now this Earth observer, we know, has measured the distance to be 3,600 meters. This is the proper length because the 2 points, XL, XR, the Earth observer is sitting there on Earth's surface, and those 2 points aren't moving. So when they measure it, say they go ahead and roll out a measuring tape along there, something like that, they can measure the length between those 2 points while they are not moving. So this Earth observer is going to measure the proper length, L0. Now for part A, we can go ahead and write that down. So I've gone ahead and written in for part A, the Earth observer measures the proper length L0 because the runway is not moving in their reference frame. Okay, so for part B, what is the length of the runway as measured by the spacecraft pilot? Well, that's going to be the contracted length L. So L is equal to L0 divided by gamma. We know what L0 is. Let's calculate the gamma factor here, which again, 1 divided by the square root of 1 minus the speed divided by c squared. Now, the relative speed here is equal to 4 times 10 to the 7th meters per second. And so for c, in this case, since we were given a real number, not a fraction of the speed of light, we're going to need to put in the value for c. I'm going to put in 3.0 times 10 to the 8th meters per second. When we put this into the calculator, we come up with a value equal to 1.0090. So it's a pretty small gamma factor, even though the spacecraft is moving at a speed of 4 times 10 to the 7th meters per second. That's 40 million meters per second. It's still pretty slow compared to the speed of light, so that the gamma factor is pretty tiny. There's not going to be a big change in the length here, observed by the person in the pilot of the spacecraft. So let's put our values in here. L is equal to L0, 3,600 meters, divided by gamma 1.0090, which comes out to a value equal to 3,568 meters. This is the contracted length of the runway observed by the spacecraft pilot. And let's go and just see what the spacecraft pilot's reference frame for this looks like. So for the spacecraft pilot, again, you've got this person, you know, in their spacecraft. We typically think of these as being moving, but for the pilot again thinks that they're at rest. In their spacecraft, and what do they observe? They see the whole runway and the Earth, right? So here's our little runway, right? That thing is moving with a speed v 4 times 10 to the 7th meters per second towards the observer in the spacecraft who's at rest. In other words, these 2 points here, they are moving. And this observer sees a shorter length between the 2 points, a contracted runway.